We are still plotting ahead with solution number 6 to apples and bananas. And if you're sick of this already, that's fine. You don't need to go further. If you understood the first 1 or 2 versions and you're comfortable with those, just stick with them. Here I'm going to be showing you, I'm going to be introducing you to the map function, which is a higher order function, which means that it takes other functions as arguments. And that's kind of crazy, and so I'd like to show you what that means. And let's see. In the book here, I'm showing you the idea of what the map function will do. It takes as its first argument a function, and it takes as its second argument something that's iterable, meaning something that you can iterate over. A list is iterable. There are some functions in Python that return, they're called lazy functions, and so they don't actually return anything until we need them. And then there's another iterable called a generator. And I have this idea here that map is kind of like a paint booth. So here we have some unpainted cars, and we want them to go into the paint booth and they come out blue. I'm showing this kind of backwards. Usually we think of left to right, but the way that we write code, usually the map, the function comes first. So paint here would be our function, and the iterable here are the cars, and they actually come out the left side because of the way that we write maps. So here I'm showing that we can create this lambda. We're using this lambda function to create an anonymous function. So the idea here is that I want to paint my cars blue, so they're going to go in as BMW, Alfa Romeo, and Chrysler. And what we want is for them to come out as a blue BMW, a blue Alfa Romeo. And the way that we do that is that each one of these, BMW, Alfa Romeo, each one of these strings will go into this lambda function, into this function, and it will come in as the car variable. And what's going to be returned is the string blue plus the car. So lambda, this from here to here is the entire function. The lambda is kind of like our def, and we don't need to give it a name. So usually like here, if we think about a regular function, like if we wanted to create a function called add1, that will return n plus 1, just whatever it's given, it will always return 1 after that. Then we have def, and then we have the name of our function add1 here. Here lambda is like the def, but there's no name. There's just the name of the parameter, which is car. Here the name of our parameter is n, and what we return is n plus 1. Here in this function, car is the parameter, and what we return is blue plus car. So since these are strings, what we're returning here is we get a new list of strings. Here, if we, in this expression, we would get a new list, so we would get a new number. So I can assert, for instance, add1 10 is going to give me 11. And I can call add1 10, and that's going to basically create the number 12. So here's a diagram showing that here's the define. To define a function, we define the function name, and the parameters come in parentheses. And we always have to have a return to what comes back from the function. And what we here the entire function body here is just the one return line. Here we have the same idea encoded as a lambda. Here I can actually assign this lambda, creates an anonymous function. I can actually assign that to a variable, to a symbol called add1. And then I'm actually able to call it in exactly the same way. So this code here, defining it as add1 and then calling these asserts will work in exactly the same way. I've just created a function called add1, and I'm using the lambda like the def function, but there's no lambda, there's no function name. This is the parameter right here, n, and the function body is n plus 1, which is here, but you notice I don't need the return. So it's a very, very shorthand way of writing a very, very short method. This is not actually recommended to go around writing functions like this, to use and assign to a variable, but this is the way to write a lambda. And I'm just showing you here that functionally they both create functions and they work exactly the same. If I call type on lambda, it is a function. So if you were comfortable using this add 1 in a list comprehension where we have for n in 1, 2, 3, and you understand that this returns 2, 3, 4 because 1 goes into add 1 and it returns 2. 2 goes into add 1 and it returns 3. 3 goes into add 1 and it returns 4. If you're comfortable with that, then it's a short step to calling this as a map function. And here what I'm showing is that the 1 is passed to add 1 and it comes in as n and it gets returned as 2. Here is another way to write this same idea using a list of actually putting the code right here as a list comprehension. For n and 1, 2, 3, return n plus 1 and we get back 2, 3, 4. Which is very, very similar to the way the Lambda code looks. So here we're saying map into lambda n, and we return n plus 1. 1 goes in, and 2 comes out. Here is this picture showing 1 goes into n gets added to 1, and then it comes out 2. 2 goes in, comes out 3. 3 goes in, comes out 4. So I can write this as a map statement, as a map expression with the lambda, where I take that all of this bit, and I'm going to shorten it up. I'm probably going to call it C instead of char. But what happens is I can call map, and I'm going to take as it's going to create the first argument to map is a lambda, is a function, which I'm going to use a lambda here, and I'm going to call it C. I'm going to paste in that code. I'm going to change these to C just to make them a little shorter. So I've written this map, and I have a lambda here, and let's just go play with that in the REPL and make sure that we understand it. I'm going to assign it, just like we had the add 1, and I assigned that to I use the add 1 as a variable, and I assign the function, the lambda function. I can do the same here, where I'm assigning new char, our lambda function, and I'm going to make the vowel that it's going to be changing to be the letter I. So if I call a new char with the letter, say, B, I should get back B, because it's not a vowel. But if I pass it the letter A, I should get back I, because that is a vowel. And if I pass it the capital A, I should get back capital I. So this is still the same code that we were playing with before, with the compound two if expressions in a row in order to handle these three conditions that we want to return. So this lambda works. It is still just a function that will handle that. What the second argument to map needs to be a iterable. So that will be, let's see, our text variable. So actually, maybe we'll just keep that on the same line. And let's run this. We can get rid of this definition. So actually, and we can just call this text is going to be overriding that. We're going to say that text is equal to mapping each of the characters in text in through this lambda, and then we should get back a new bit of text. So let's save that and run it. Let's see how we do. That seems to work. Let's change that to foo bar, and let's change the variable to u. Great, Ferber. And let's run make test and see how we're doing. So that works just fine. So the thing that I'd like to point out here that's also just a little bit tricky here is that the second argument to map needs to be something that's iterable. And this technically is a string, but strings in a list context will be turned into their characters. So each character from text gets mapped into this lambda as C for char, and then we execute this statement, the function body, and what comes back is either the vowel or the vowel upper, or the character itself. And that comes back as this is now going to be a list. So text has gotten changed from a string into a list, and so we have to put it back together using a join operation. If I were going to write this for actual code, I would probably do it like this, args.text, so that I really only see the text once. So I'm just taking args.text, mapping that through the Lambda, and I'm getting back the new value of text, which is a list, and I save it. So let me save that. And again, this being the whole point of test-driven development, I want to make a change to the code. I want to make sure, does this still work? Yes, it still passes all my tests. So that is an introduction to how to use a map using a Lambda. Next, I'm going to show you how to use it with a defined function, which seems to clean it up a little bit. So stick around for that.